Exterior, night. An eerie pall is cast over an all-too-familiar suburban landscape. But how? And what if it wasn't? Let's look a little closer. Tonight on the hovering skull hour of chills and thrills. 3 easy ways to add horror ambiance in Godot. Hello! Whether you're watching this in the season of ghosts and ghoulies or in the oppressive summer months, I care not. We keep the macabre, the eerie, and the unheimlich alive in our hearts all year. Tonight we're going to cover some simple effects in Godot that can turn a game environment from boring, cozy, etc. to a spine-tingling playground for the ghoulish and a weird mix of 80s and early 2000s nostalgia that seems to be the default for these kinds of things. I don't know. This is true vibe coding in that we're coding vibes, not using AI. First, we're going to introduce layered volumetric fog effects using an environment resource. Next, we're going to give our lights an unsettling flicker effect by sampling noise textures. Next, we're going to add an anachronistic CRT overlay with a canvas shader because everything from the 80s is slightly more scary. Ooh, synth pop, the resurgence of neoliberalism, Saturday morning cartoons, me. I'm technically from the 80s. Terrifying. Most of my content is code focused, but this will require us to write very little new code. Visual and atmospheric adjustments are usually better to do in the editor using Godot's tools and maybe plugins, which we won't cover right now. You can download the starter project from the link in the description. It's based around a CC0 asset provided from elbolioduro.h.io. Te demos gracias, Señor Elbow. Let's get started. Fog. We can use it to hide embarrassing draw distances, obscure, terrifying monsters, or create an atmosphere of creepy moistness. And it's easy to add fog to a Godot project. Dead easy. The key is an environment resource. We can create one in our file system, just like any other resource. Look up environment. And then it can be attached to our camera or to a world environment node in our scene. We'll try out the world environment node. So if we want to add one, add a child node to your scene, and it's just world environment. Okay, it already makes a little change here, and then we can drop in our environment T-res into environment here, and just click on that, and now we have a whole bunch of options. This post-processing stuff can be very powerful, and you can do lots of cool things with it. We're most interested in fog and volumetric fog, but there's a lot of stuff you can do to color grade and mess with your visuals. Just be aware that some of these are going to incur a significant performance cost, so if you do add them, you could think about giving players an option to turn them off or tone them down. So let's turn on fog here. Standard fog works by obscuring objects based on how far away from the camera they are. We can also use height fog, which does this based on the y-axis, which can give your game the pleasant look of a gloomy valley at dawn or something. And yeah, we should apply some basic fog. I'll lower the density a bit, but it already is looking a little bit gloomier. I like that. Volumetric fog, on the other hand, is fog that takes up, well, volume in our game world. It also interacts really nicely with local lighting in your scene, which can be quite a cool look. It has different values to play with, but the main one here is density, which makes it thicker, and also the emission and albedo can be played with to give different color looks. We can choose a eerie bluish color. This is all up to what vibe you want to convey with your game. This is great. This is a lot of fog, but you'll notice also that the fog is coming into the house. This is supposed to be volumetric fog, not universal fog everywhere. How do we discriminate? Well, Godot has a really handy tool called fog nodes, which we can now add to our scene that will let us add or reduce or alter fog in volumes in our world. So we can look up fog volume nodes, and that will give us a little node here that has a shape in it. We can change the shape like any other mesh, but we can put it somewhere we see. And this is just defaulting to a cube, but you'll see in that cube it has a different type of fog in it. Now, you can add a fog material to alter this, and if you want, you can change its density and make it really thick or really thin. You could turn it into a different shape too. There's cylinders. Again, here is a sphere of fog floating in this room. It doesn't look so scary, though maybe a little bad for your lungs. This fog's way too thick. Okay, cool. So we can do something more useful though, and that's to turn it into a box like this and make it take up the space of the entire room. A radical hotbox. Then instead of adding fog density, we can reduce it to negative, and that will eliminate fog from the room. So this way the room stays clear, but the outdoors has as much fog as we want. So this is a pretty handy tool to control the fog by volume in your game. Excellent. A fog-free room. Let's move on. Well, nothing is as scary as our technological conveniences failing to work in slightly unpredictable ways. Last January, my dishwasher broke, and it took 6 months and about 15 angry calls to get it fixed. Anyways, let's make some lights flicker. So we've got these 3 lights in the room here, and I'm going to make them have a sort of natural feeling flicker. We're going to add a script here. I'm going to write this in GD script, but it should be easy to rewrite in C#. Just change the capitalization a bit. And in my first attempt at this, I thought maybe we just use a random number generator and change the energy value of the light based on that. So I'm going to try that here. And you'll see why it's kind of a bad idea. If you are photosensitive, don't look for about 5 seconds. Yeah, I mean, that doesn't look correct at all. It doesn't look scary, it just looks annoying. So I think we need something better, and my thought then is to sample from a noise texture. So noise textures are a really cool way to have kind of constrained randomness, and we're going to use the fast noise light class that's in Godot. So we can do expert var noise, fast noise light. This lets us have a custom noise texture that we can sample from. And I'm going to create it as a resource so that we can use it for each of the lights separately. So it will be a fast noise light resource. Ignore the one I already have, and we'll call it light noise 2 in this case. Now, if we click on this, we can see the noise that it's generating. This is simplex smooth noise. We have a few different algorithms we can pick, and each one is going to have a slightly different easing between different values. But let's just look at how we're going to sample from this. We can do noise.getNoise1D. That's going to sample noise in like a line, essentially, pixel by pixel. And then I think I'll grab, I'll get some time value. It doesn't matter that much, but we'll do time.getTixMsec, which is the number of milliseconds, I believe, since the game started. And there you go. So we've got X, which is going to be some number that is based on the value it's seeing on the texture at that time value. And then let's just set the light energy to be that X. Well, this might actually not work that well because X could be a negative or something. So let's clamp it between 0 and some sort of max value. I'll do it, call it max energy, and then max energy I'm going to set in ready to be the whatever energy we set as the light's normal energy. Cool. Doesn't like that because I need to give it a var for max energy outside of the functions. Perfect. Okay, so now if we play this, it isn't working because I haven't actually applied the noise textures to my scripts, so let's get that working. Okay, so if I drop the light noise 2 texture onto my scripts here, and I play, you start seeing a bit of a flicker here, but we definitely want to mess around with the noise texture a bit to get a better flicker. And this is just on one light, you'll notice. So if we go back to our light noise 2 texture, you can see that we can start playing with all of these neat variables. Now, the math for generating noise is quite interesting, and I don't fully understand it, at least not enough to explain it to you right now. But this is the kind of thing you can just play with. If you change frequency, you'll notice that it changes way faster. It's sampling fewer pixels between each thing, so it can change quicker. Also, there's this ping pong strength, which I like. I set fractal type to ping pong in this case, and then gain will make it flashier. Again, I like to make that a bit low. I definitely want the ping pong fractal, and I set my frequency to be fairly low because I think that looks quite nice, and it gives them slightly flickery, not super flashy lights. So I think that's all right. And I'm using the cellular noise type also, because that gives you these kind of hard edges between cells, but also soft gradients in the middle. So I'm going to set these to all of the lights, the same script and the same noise, and you'll see that the whole screen has a little bit of a flash now. Great. Okay, I think that is somewhat functional flickering. Again, with any of these things, you have the opportunity to play around and mess around and make something that feels right for you. But those are the knobs that you can start turning at least. So the last thing I want to cover here is how to put a spooky looking 80s CRT shader on your screen. Learning how to write shaders in Godot requires you to learn a whole new language and programming paradigm, and that's really out of scope of this video. There's lots of people who can teach you that though, and maybe I will eventually. But you can just take shaders off the internet. GodotShaders.com, as well as some other places, have lists of shaders that are free for you to just grab and use. A lot of cool people contribute to this site. So have a look here. There's a few kinds. You can see spatial shaders here, you can see fog shaders, but canvas shaders are what we're looking for here. And I'm going to look for a CRT one. There's this one here that I have used a few times. It's very extreme and looks quite ridiculous, but you can really tweak it to do whatever you want. And you can see there's just this big chunk of code here that we can just copy into our game. Don't worry too much about understanding this, but if you do feel curious, you can just play with it. In order to get this in our game, we can just copy it, and then we can go back into Godot. We want to create a shader resource, not a shader material and not a visual shader. It has to just be shader. So shader resource here, if you create that, and we can call it something like CRT, doesn't matter, but yes, whatever you want. And then in here, we can paste all of that code, just the whole thing. Anyways, now we have a shader script in our game. What do we do with it? Well, let's go to our tree. At the top, we can add a child node. Child node we want is a canvas layer, and we can click on that to see it. It takes you into 2D mode here. And well, canvas layer won't do anything by itself. We can add a child to it. That child is going to be a, we want a color rect, I believe. Yeah. Take a color rect, click on layout, and then the important thing here is you go to anchors preset and go full rect, and that should cover the entire screen. Okay, so if we play the game now, we should see a big white block because that's what the color rect is giving us. And that is correct. Now we need to change this so that it renders with our shader. So all you need to do this is go to material down here, click on material, shader material, click on the little ball that it generates, and change the shader to quick load CRT. And you can see that there are tons of little knobs for us to twiddle here that are defined in our shader. But now when we play, we see that the whole screen has been warped into this awful looking shader. Cool. Now, the thing you want to do here is just start playing with some of these knobs. I'm turning off pixelate, I'm boosting the resolution. You can do anything here. That might improve it a bit. Again, it's quite strong of an effect. There might be a bit too much chromatic aberration. We can drop that. Again, all of these are fun little knobs to twiddle until you get a visual that you like, that is making you happy for your game. And if this shader isn't pleasing to you, there are hundreds more online that will do similar things. Just make sure that they are canvas item shaders and not spatial, because spatial shaders are for 3D objects, not for processing a screen or sprites. Well, thank you for joining me on that journey through Godot's more spooky features. If you've got a horror game you're working on and you want a more visual panache, you can probably pretty easily add some post-processing, mess with fog and lighting, and maybe even toss on some sort of shader. Really easy for the amount of effort. And if you do make something super cool, show it to me. Send me a link in the comments or on my Blue Sky or whatever. And if I get a bunch of cool ones, I will make a little video about them. I'll get back to more coding stuff soon, but for now, happy Halloween. Like and subscribe to me. This is Mortimer, and I'll see you soon.